Hi, everybody. Sorry I'm missing your class today. I hope that you have this paper out in front of you, and you should have some of the tiles out in front of you. I just want to remind you about the pieces that we've been working with. We have X's that are positive, that are green. We have negative X's that are red. Remember this? We have a positive 1 that's a yellow square and a negative 1 that's a red square. Everybody remember that? Okay. So first thing I want to do is remind you about subtraction. Remember that when you subtract something, I'm going to highlight this subtraction that's in here, right here. That's the same as adding the opposite. Like I could rewrite this problem as x plus 4 plus negative x plus 1 in those parentheses like that, plus a negative. Can you see that? It's right here, plus negative. Well, just made a mess out of that. That's okay, plus negative. That means add the opposite of something. So in this particular problem, we started with x plus 4. So I drew the picture. You can actually draw that right on your paper. Well, it's already drawn on your paper. And I just want to show you that there's the x plus 4. In this particular problem, I have enough tiles to be able to take away an x plus 1. That's what I looped right here. That's what that loop is right there. X plus 1 is getting taken away, which means what I'm left with are these 3 units right here. I'm going to highlight that again here because this is what I got left with. That's my answer. Notice how my answer was 3 over here because that's what I got left with after these things were taken away. So thinking about subtraction as just take away, that's fine. I can do that. I can also think of it as adding the opposite though. And so I'm going to do that now down here. The next one down here, we're going to do together. I'm going to rewrite this as 5 plus 2x plus negative 3 plus x. So adding the opposite, 5 plus 2x plus negative. There it is. Okay, so let's start off. 5 plus 2x is going to look something like this. I've got 5, and then I've got 2 x's. There's 5 plus 2x, right? And I'm going to add the opposite of 3 plus x. So the opposite of 3 would be negative 3. Oh, sorry. These things get stuck on my paper here. There's negative 3 because I'm adding the opposite of 3 and the opposite of x. Everybody see that? So this is the opposite of 3 plus x. I could have put it down like this. Here's 3 plus x. I said add the opposite of it, so I could just flip them over, and that makes it the opposite of. So there's 3 plus x. So let's talk about, well, let's get this written down here. I have 5 and 2 x's that are positive, and I'm adding the opposite of 3 and an x. That made all those negatives because those were the opposites, right? So you can still see that right there, right? Okay, so now let's make our 0 pairs. I see a 0 pair of x's right here. I'm going to get rid of those. I see a 0 pair of a 1 unit, another 1 unit, another 1 unit. That's gone. And look at what I'm left with. Just a green and 2 yellows. So that means my final answer is x plus 2. All right. So let's look at what I did. I made these two a 0 pair. And I made 3 of these and 3 of these a 0 pair. So that left me with 1, 2 units and an x. There it is, that x. Okay? this is how we're going to write that symbolically. 5 plus 2x minus 3 plus x is going to turn into plus negative, right? 5 plus 2x plus the opposite of 3 plus x. Well, what did that turn into? It turned into 5 plus 2x minus 3 minus x. It's almost like I was distributing a negative sign. Okay, so now I've got some like terms I can combine. I've got 5 and minus 3. There's my 2. And I've got plus 2x minus x. There's my x. And all I did was swap their order, right? Because of the commutative property. And now I have my answer of x plus 2 for the difference. Go ahead and give the next one a try, and we'll come back to it.